Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and watching my videos continuously. Today's topic of interest is types of fluid flow. Types of fluid flow. How the fluid flow is being classified. Let us see here. The type of a fluid flow is classified as below: the steady flow, unsteady flow, uniform, non-uniform flow, laminar, turbulent flow, rotational, irrotational flow, compressible flow and incompressible flow, and finally the one dimension, two dimension as well as the three dimensional flows. Here is the steady flow. I'm going to compare the steady and unsteady flow. Here, the various characteristics, that is, fluid characteristics, if it does not varies with the time, it is called as a steady flow. If the fluid characteristics changes with time, it is called as an unsteady flow. What are the fluid characteristics it is having? If the density, temperature, velocity, pressure. So these things are considered to be an characteristics of the fluid. If these characteristics, if it varies with time, it is called unsteady flow. If it does not varies with time, it is called steady flow. So I hope you have clear. With the help of a time, with the time, that it is not varying, the properties does not vary, the characteristics does not vary, that is called a steady flow. If it varies, it is unsteady flow. Next, an uniform flow or non-uniform flow. Here, the flow characteristics, the fluid flow characteristics is a matter. That is, a flow characteristics means the velocity. If the velocity does not changes from point to point, it is called uniform flow. If the velocity varies with point to point, it is an non-uniform flow. Here, we are taking a straight long pipe, of a constant area, of a constant area, and this is the section 1 and this is the section 2 having the same area, if we can say same area. So the velocity, if it does not varies with time, that is v1 is equal to v2 with respect to the distance l. If it is not vary, this is called uniform flow. If it is not equal to, that is called non-uniform flow. I hope you have understand this. If the density, here the density, if density remains same, that is called steady flow. If density is not equal, it is an unsteady flow. Or pressure, we can say pressure, P1 is equal to P2, this is steady flow. If it is not equal to, it is unsteady flow. Very simple about the steady, unsteady and uniform and non-uniform flow. I hope you have clear about this. Yes, yeah, thank you. Next is a laminar flow and turbulent flow. A laminar flow, we can say a smooth flow, one layer of fluid sliding smoothly over another layer, which is called laminar. If there is any continuous mixing or any zigzag way, if the fluid layer is follows, then it is called a turbulent flow. A rapid and continuous mixing of a fluid, that is called a turbulent flow. If a flow, if it is varying zigzag manner, we can say it is a turbulent flow. Whenever you see a open channel, if the flow is heavy, the fluid particle, a fluid layer will make a zigzag path. The top layer will make a zigzag path. That is why that is called as a turbulent region, turbulent flow. In the same canal, in the bottommost part, there is no disturbance. The fluid layer is moving smoothly on on that point. So that is called a laminar flow. Or we can say if a fluid is passing over a capillary tube or a small, relatively small tube, we can say it is a laminar flow. Here the next type is a rotational and irrotational flow. If the fluid particle, this is the fluid particle, say Q and P is the fluid particle, it rotates about the mass center. Where is the mass center? So here is the mass center. If it rotates about the mass center and moving in the direction of flow, this is called a rotational flow. If it does not move about the mass center, and this is called as an irrotational flow. So the rotational flow is the fluid particle rotate about their mass center while moving in the direction of flow. That is called rotational. And irrotational is fluid particle does not rotate about their mass centers while moving in the direction of flow. So that is the rotational as well as irrotational flows. Next is the compressible and incompressible flow. Generally, if the gases are flowing the compressible flow and the liquids in flow, it is considered to be an incompressible flow. How we can say, if the density does not varies, if the density is constant, density of the liquid do not change due to the change in pressure or temperature, that is called an incompressible flow. If it varies, it is an compressible flow. Generally we know that the gases are compressible in nature. Due to the pressure it can get compressed. If it compress, it will increase the temperature as well as the density is getting increased. So the density is not at all constant about the fluid flow. That is why whenever in the region if the gas is flowing, so that is an compressible flow. Where the flow of liquids is an incompressible in nature. Next is a one dimension, two dimension and three dimension flow. The flow characteristics varies in only one of the three coordinate directions, that is called one dimension. If the flow characteristic varies in two of the three coordinate direction, that is called two dimension. If the flow characteristics vary in all the three coordinate direction, that is called three dimensional flow. So this flow can be illustrated as the steady as well as unsteady flow. And for the steady flow, if it is in one dimension, the velocity, the flow characteristics velocity is the function of x only. For the two dimension, the velocity is the function of x and y, and for three dimension, velocity is the function of x, y, z. If it is an unsteady flow, the velocity is depends on, velocity is the function of x and the time, and for the two dimension, velocity is the function of x and y and respect to time. For the three dimension, velocity is the function of x, y, z and time. Here we have to understand that the linear lines, if the fluid particle are moving in a linear straight line, that is been considered as an one dimensional flow. If it is in a quadratic or a parabolic in nature, that we can call it as a two dimensional flow. If it is in a cubic parabola, we can say it is an three dimensional flow. So with this, I'm going to stop the types of fluid flow. If you have any doubts, please let me know in the comment section. I will make another video for clarifying your doubts. If you like the video, please like, share and subscribe to Mekiteki channel. If I get more subscribers, it will provide me a greater encouragement of creating these kinds of technical videos. And I would like to thank you all once again. Thank you.